So we're Prescient Devices. And for those of you who don't know us, we work on low-code IoT software and system. I think many of you probably have heard about low-code a lot these days. It's certainly a pretty hot topic. According to Gartner, about 2/3 of all software development is going to be in low-code. If you think about it, that's pretty astounding. 2/3 of all software development eventually will be in low-code. And also, 3 out of 4 companies are going to be using low-code in the next few years. The reason why low-code has risen so fast is because today, every software application is a web application. And developing a web application is very complicated. You have all the back-end technology you have to take care of. You have all the scaling you have to take care of, all the DevOps. You have to connect to a lot of different APIs, different services. So up to now, software development, web application development only remains in the hands of very dedicated software development teams. And that means most of the companies are unable to work on software, custom software. And so now low-code comes in to help those companies because you can build the infrastructure separately from the application, right? So IT engineers, OT engineers can build an application one way and deploy to this enterprise class infrastructure. And then you have an enterprise class solution. And I think the savings in time is more than a factor of 10. Savings in cost is usually also around a factor of 10. And this greatly accelerates companies from building their own applications, using them for their own custom needs. This is very similar to what IoT needs. Today, IoT, again, is only built by a few companies who specifically focus on IoT. But a lot of problems need to be solved by companies themselves, by the IT teams, OT teams. So low code is critical in solving those problems. That's what we do. We actually start with a very popular open source low code software, but we make it scalable, we make it reliable, and we make it possible for pretty much anybody to build solutions. In fact, most of our customer solutions are built by 1 or 2 engineers. It's incredible how some of the solutions are very complicated. Lots of devices, lots of complexity, but just 1 or 2 engineer can handle the whole solution. So you will see some of that in this webinar. And the next thing I want to quickly mention is about machine vision. I think machine vision is just one of the tools in IoT. It's a popular tool. Traditionally, it's very hard to handle. But today, as you will see, it's basically drag and drop. That's what we made it to be. And even model training has been simplified a lot. Not necessarily from just our work, but from the industry. Anybody can pretty much train the models, then they can bring the models into our software, drag and drop, and deploy it to the cloud or to the edge to many devices with a click. And so this makes it very simplified. And machine vision basically just gives all of us like another pair or thousands of eyes out there to check on what happens. So we'll show you how that's done. Now I'm going to introduce today's speaker. Today's speaker is Ashish Yadav. He's our director of software, and he's a full stack software developer. Full stack simply means someone who can develop from the cloud backend all the way to the application front end. But Ashish also has a lot of experience in the entire IoT system, down to the edge devices, down to embedded software, as well as a lot of the machine learning, machine vision work that we do with customers. So today's webinar is broken into several sections. In the first section, Ashish is going to give an overview on Node-RED, machine vision, Prescient Designer, which is our software, the customer-facing software. And then we'll have a short break for Q&A. After Q&A, Ashish is going to show you a machine vision demo that basically you can deploy in the cloud, you can deploy to the edge, you can simulate in the cloud and deploy to the edge. Very simple to do. And we have a questionnaire at the beginning of the webinar. Please fill it out if it's relevant to you. We'd like to get some understanding of where you are in the IoT journey. We have a survey at the end of the webinar. Please fill that out to help us as well. And because of the limited amount of time, we would like you, if you like to ask questions, we would like you to submit it through the Q&A form so we can both try to answer them in real time and also discuss them during the two Q&A sessions. So now I will leave the stage to Ashish.
All right, hey guys, and thanks Andy. Thanks for the warm introduction, and thank you all for being here. I hope everyone is doing well. So as Andy mentioned, the agenda for today is in two folds. So we'll look at Node-RED and TensorFlow. We'll look at how the combination of Node-RED and TensorFlow makes machine learning accessible and easy. We'll do a quick overview of the traditional workflow, how you develop an application in Node-RED, and how Prescient Designer can help you scale that application from a single device to 1,000 devices. We'll also look at what we are building today. I'll go through the process of how we did what we did. We'll have a quick Q&A break, and we'll go to the exciting demo after the Q&A. And yeah, again, we'll have another set of Q&A before we close down. So Node-RED, for those of you who are not familiar with Node-RED, is a graphical environment for event-driven applications. So it was built in 2013 by IBM, and it's mostly been built on the backbone of Nick O'Leary and Dave Conway. So just want to thank these two individuals who have put a lot of effort and time in creating and building a vibrant community. I mean, Node.js has almost more than 2 million downloads. There are 3,000 nodes that do basic hello world to complex analytic stuff and machine learning, machine vision stuff. And it's built on top of Node.js, which is like a standard in web development these days and also in backend. Coming to TensorFlow, everyone knows it's Google. It's a popular open source machine learning framework. It lets you train, build, it lets you run the models, and it is supported in different languages, different environments, and the whole community around is huge and it's growing each day. So the combination of these two, Node-RED and TensorFlow, it gives us a graphical environment for machine vision, which is great, but it's still a single system because Node-RED is a single system application. So you can run it on the edge device and that's it. To scale it to an IoT system, like a full IoT a stack, you have to have a domain experience in a lot of technologies from security to communication to dev operations. You need to understand how machine learning works. So this is where Prescient Designer helps to bridge the gap between Node-RED machine learning and the IoT system, running the application on the edge. So before I dive into the demo, overview of the demo, I just want to thank to the awesome community that's involved in this project. So we are no machine learning expert, and this has been made possible because of the amazing people that are involved in Node-RED and TensorFlow. I mean, Node-RED Slack, Node-RED Discord channel is huge with a lot of helpful people. And just want to do a quick shout out to Kazuhito Yukoi. I'm sorry if I'm butchering your name. So he's a researcher at Hitachi, and he has a bunch of useful and neat TensorFlow nodes, some with pre-trained models. And I've used some of his nodes in one of our previous blogs. And Paul Van Eck, he is an IBM software engineer. He has amazing YouTube tutorials. So just wanted to quickly thank them for their contribution to the open source world. I mean, their tutorials and nodes on machine learning and Node-RED have helped and accelerated us in our development. So yeah, thank you guys. So these days, machine vision or machine learning, it's used it's used in everything and everywhere. So in industries, it's used to detect faults, to track assets, for predictive maintenance, inspection, and in healthcare for detecting diseases. It's used in insurance for loss prevention, and most popularly in automobile industry for self-driving cars. I mean, the applications are numerous. Now, the example use cases, I mean, we are working on an application, started working on an application recently, which is monitoring the quality of the components with a camera, like a chipset, and raising alerts or moving the chipset out of the production pipeline, doing some analysis on the chipset. So yeah, it's everywhere, and it's up to the application or the user's imagination on how to use it for their application. So Node-RED and TensorFlow makes it possible to design applications relatively easy, whether it be machine learning or anything else. But with that said, an IoT system has many devices. It can have many different sorts of devices, many different sorts of sensors. And Node-RED by itself only focuses on a single edge device. So it makes it difficult to scale to full host of devices or a large deployment. And I mean, the experience and the resources required to do that include and are not limited to DevOps pipelines, infrastructure management, understanding machine learning, security, communication protocols. So you need a team of developers who is just taking care of these things, and then you can figure out your application. And talking just about machine vision, you have to run inference at the edge, so you have to make sure that your model is at the edge, right? You have to make sure that you can communicate from your edge device to the cloud, or from your edge device to the database, or from your cloud to the database. So there are a lot of moving parts. You have to make sure it's secure, no one is tampering with your edge device or with your data. And let's say you want to do retraining. Now, in a traditional application, if you have a new model, you'll have to send that model to each and every device. So for that, you'll probably have to log into, let's say you have 20 devices. So you log into 20 devices, you update the model in the device, you make sure that all the dependencies are there, and then you can work on the application. So it's a painful process, and it's a cycle. So this is where Prescient Designer comes in. So in Prescient Designer, you provision your device. It's a one-liner script, and I'll go through the process in the demo as well. So you provision your edge device, and you get access to a cloud application. So this is a SaaS application, and everything is in one place. So you can see your whole stack from cloud to the edge. You can collaborate. I mean, different users can work individually on the designer. You design your application in the designer, which is the cloud app. You hit deploy, and boom, everything from your design goes to your edge devices. And you can have n number of edge devices. And let's say you want to optimize or iterate your application. You want to add a bunch of more sensors, or let you do some database analytics or anything. So you can iterate just on the designer. You hit deploy, and that's it. Your edge devices are updated. So we take care of the application and everything, the modules that are being used in the system. So this allows you to concentrate on the application at hand and not on the IoT system. So it's quick, it's painless, it's seamless, and it works. So you don't need an army of software developers, hardware engineers, architectures, and you can concentrate on your application. All right. So how we do this? So we are built on top of Node-RED, and we add a whole bunch of features to make it enterprise grade. We add security. I mean, there are different security mechanisms in place in Prescient Designer and on our edge runtime. that make sure that everything is secure, and if someone tampers with the data, you get notifications. There's a built-in communication, so we take care of the interaction between the edge and the cloud. So you provision a device and that's it. We take care of the communication and the interaction between different devices or between your cloud to your edge in the back end. We have distribute programming, and Pablo, our VP of engineering, touched this topic in details in our last webinar. So if you're new to the system, I'll highly recommend you can check it out. You can find it under resources on our website. So today I'll be talking about template solution and machine learning. So I'll be using one of our template solutions. So it's a pre-built like starter kit. So it helps customer to get started. So you have a project in mind. We have a template solution for that project. So you don't start off with a blank page. You can build your solution on top of template solutions, and that makes it much easier. So I'll be using one of our template solutions, and we'll be building a machine vision application. So yeah, hopefully I was able to put some light on the rest of the features in addition to Node-RED, what we provide. And today we'll focus on template solutions and machine learning. So one of the important steps to get started with machine learning is training the model. So you can use pre-trained models. I mean, there are a bunch of them available on TensorFlow Hub. There are some open source nodes contributed by the Node-RED community. I mean, they are a good starting point. But most of the customers need custom training. So they have custom data set, they have custom application. They need to train their model themselves. And there are a bunch of services that help you in doing that. So RoboFlow, Google Auto, Machine Learning Vision, there are SageMaker. There are some services by Microsoft and IBM as well. But it still requires some sort of knowledge on machine learning. And recently I came across Lobe.ai. It's a web application. It's a desktop application actually, and it's simply drag and drop your images. It automatically labels them, and it runs the model. It runs the training, and it gives you a model file in a bunch of different formats. So there are a bunch of tools that can help you get a model file and to get you started with Node-RED. So on top of this, we also support customers in custom training. So if you have a specific use case or an application and you would like us to generate some data for that, we can help you with that. We can also help in data segmentation, augmentation. So we can cover you and support you in different steps along the way. So for this demo, we have generated data on walls. So we have these are water walls. So these are called ball walls. So we have generated data. We have scraped the internet for images for wall walls. We have generated custom images. We label the data with open and close and unknown. So there are 3 states. A wall can be open, it can be closed, or it's not there, or something is blocking the view of the wall. And we train the model in TensorFlow, and we get a model file, and that's what we are using in this demo. By the way, we'll be sharing this model file in one of our upcoming blogs, so you can play around with it. All right, so now that we have the model file, we'll be running inference on that model file. So inference is nothing but a process of running live data into an algorithm to get an output. So in this case, our live data is images of wall. So this can be from the camera or a file. So it goes through a model generates an output, and it will tell us if it's open, if it's closed, and if it's unknown, right? And TensorFlow is included in on our application and edge devices, so you don't have to worry about dependencies, and everything is inbuilt. So this is something that we will be working with today. It's deceptively simple because we take care of everything. We take care of the communication, the dependencies, the security. So you import this template from the template browser. I'll be going through that. And it just works out of the box. And we'll look at how it works. So just to summarize our system, this is what we'll be working with today. So I, as a user, I'll be using Prescient Designer to design my application, to build my application, and I have a bunch of devices provisioned to my designer. By provisioned, I mean the designer and edge device can talk to each other. So there's a communication pipeline between each designer and the edge device, and all the edge devices can talk to each other as well. So I'll be using one of the edge device that has a camera attached to it, and we'll be running inference. We'll be running machine learning model on the edge device itself. We'll take an image from the edge device, we'll run inference, and we'll send the output to the cloud, which is Prescient Designer. And on top of this, we can build a whole host of features in the designer. So we can have analytics tool, we can push the data to the database, we can do it from the cloud or directly from the edge. So the data doesn't even have to go to the cloud. I mean, let's say you want to save bandwidth or and some data in your communication pipeline. So you can, instead of sending data from your edge to the cloud, you can directly send the data from your edge to your database for post-processing. You can also set up dynamic training. So you keep retraining the model as the new data comes in. It makes it more powerful, more flexible. So our end result will be a simple dashboard with an image view and inference view. So the image view will be the images, what we get from the camera or from file upload. So that's the view that you see here, and the inference view is the state. So it'll tell us if the valve is open, closed, or unknown, and it'll also tell us the certainty. So certainty is the probability of classification. So how certain our model is that the state is closed, open, or unknown. Now, again, this is a very simple demo, but this can be extended to have like a bunch of different features. So you can have alerts in place. You can have a feedback retraining. So as the data comes in, you keep pushing the data to training and you keep updating your model real time. You can have database backups. Like in this application, every event is being backed up to the database, and there's a log. There's a whole list of log and of all the events. There are some analytics tool built in. I mean, it's scalable, so you can scale this solution from one device to n number of devices, and that's just by a few clicks of a button. And this is flexible. So let's say you have another sensor you want to include in the system. All you need to do is you need to plug that sensor to your provisioned edge device. You come to Prescient Designer, you design the application in Prescient Designer, you hit deploy, and the new application goes to your edge device. So it's that simple. So to summarize, we help you to focus on the application at hand. I mean, if you have a project in mind and if this looks helpful to you, we definitely encourage you to get in touch. We do a technology assessment and we look at how we can support you. But most customers, when they get onto the system, they don't require much support and can work independently. Because again, it's on Node-RED, and Node-RED by itself is graphically driven, so it's just moving through a few blocks around. And we have different support levels, so it can be as much or as little as you need. And we support customers in hardwares, template solutions, drivers for their hardwares. With that said, we'll pause for a quick Q&A before moving on to the demo. You're free feel to check out the website. I mean, we have a bunch of resources and use cases. Yeah, thank you.
Thanks, Ashish. If anyone has questions, please post them to the Q&A window. One thing I want to say is that if you're a Prescient Designer user already, I see some of you are, you can download the templates directly from the templates folder. So go to import, and there's two files there. One of them actually uses Yoko-san's TensorFlow node that he contributed, and you can detect many different things. Just drag and drop, put a camera on there. You can detect cups, chairs, and all sorts of things. And then the second template solution is the one that Ashish is going to show. It's one where you can actually put in your own model to detect something in specific. So those are available. Those are also available on our website. If you're not a Prescient Designer user, you can download the flows, which should work mostly in Node-RED, I think, other than the distributed deployment feature should work there. There's models there. So please check those out. And right now, I don't see any open questions yet. I think Ashish, you probably get more questions when you go into the demo section.
Sure.
Maybe we can continue for the sake of time, and then we can wrap up with questions at the end.
Yeah. Let me share my screen again. All right, can you guys see my screen? All right, I'll take it as a yes. Before we dive into the template solution, I'll give you a quick overview of Prescient Designer. So what you see on screen is Prescient Designer. It's built, it has a host of different features added on top of Node-RED. I mean, as you can tell, this looks like Node-RED, and we want to keep it that way because users are familiar with Node-RED, and the open source community's Node-RED is huge. What you see on the screen is Prescient Designer. So we have built-in communication. So we take care of the interaction between the cloud and the edge. We have some security implementations. So you get notified if anyone tampers with your system. We had distributed programming. That's what enables you to scale from one device to 1,000 edge devices or n number of edge devices. We have package management, and we manage the dependencies, so you can concentrate on your application. You don't worry about installing required packages per edge device. We take care of all of that in the background. We also have a very fancy navigation bar, so it gives you access to your dashboard. You can go to documentation from here. You can also select a different designer. So one user can have multiple designer instances, or multiple users can work on a single designer instances. For example, let's say different departments in an organization can have multiple designers account, and multiple users in that department can work on the same designer, right? So that's built in. We have a device panel. It's a device management plug where you can see the status, and you can monitor and manage your device, your provisioned edge device. So right now I have 3 devices provisioned to my account. I have 2 Raspberry Pis, one is Pi 3, one is Pi 4, and I have an industrial gateway. So it gives you status of each edge device. It tells you the memory, the disk usage. It tells you when was the last time the edge device was seen. It also gives you security alerts. So if someone tampers with your edge device, they change the code on your edge device, this green lock, it turns red. So you get notified and you can take an action. Also, we have edge monitoring. So the tick mark that you see, it monitors the edge application. So this helps in reliability of the application that's running at the edge. So if something happens to it, if it's down, you get notified real time, instantaneously. We have another hidden settings. So you can decommission the edge device, remove it from the system. delete unused modules. So let's say you have a bunch of edge devices that have TensorFlow running or a Modbus driver installed in the edge device, but you want to save some space, so you can hit this button, and this will remove all the unused modules that are in the edge device. So to provision the edge device, it's a single line command. So you go to your settings, you go to system tools, you hit provision edge device, and each designer has its own command with its own key that get rotated. So yeah, so that's get rotated. So you can run this command in a single edge device, and that's probably the only time you'll have to run this command on the edge. So once it's done, you hopefully you won't have to touch that edge device again, and you'll do everything on Prescient Designer, right? So moving on for this demo, I'll be using a checklist to make some important checkpoints in our in the demo. So hopefully these checkpoints will help you making the demo more descriptive and easier to follow along. Before I go to the demo, firstly the setup today, I have Prescient Designer. It's the application that you see on the screen here. It's running on the cloud. You can access it from, it's a web application, so you can access it anywhere on your iPad and wherever you are. And right now I have a device, which is a Raspberry Pi 4, and it's hooked to a camera, and it's looking at a valve that's on a table in our innovation lab, which is also my garage. So this is the set for today. So Prescient Designer running on the cloud, edge device hooked to a camera, and it's looking at a valve. So to get started, first what I'll do is I'll import a template. So to import a template, we go to settings, we hit import, we go to our templates browser, and we have a bunch of different templates for machine vision. As Andy mentioned, we have one for image classification, and that has been built on top of that is using the open source Node-RED nodes for detecting to classify common images. We have some utilities to transfer files to the edge. I mean, we are currently working on, like the most recent one, we are working on vibration sensing for fall detection, and machine learning on audio signals, so to detect environment conditions, and that's going to be a fun one. Anyways, I already have a template in place, so what I'll do is I'll select this template, and if you hit import, I won't do it because it's already in the system. You should see a template like this on Prescient Designer. So it's a very simple template. So just to talk about it a little bit, and we can look at how everything is hooked up. So we have different nodes. Some are running on the cloud, some are running on the edge. I mean, they can run on the edge. Right now, everything is running on the cloud. We have two inputs. One input is get image button, which is what you see here on our dashboard, and image view, which is what you see here. It's where you'll see the image once they pass through the system, or once you upload an image or get an image from an edge device. We have an inference view, so this tells the state and the certainty of the inference. And all of these dashboard nodes, they are basic Node-RED nodes. I mean, they are available in standalone Node-RED. So there's nothing special going on here per se. And we have a device subflow, and this is a subflow that you can actually transform into a device. So to quickly go over the subflow, it has two inputs going into it. So one is get image, this one, and another one is you can upload a file from the browser. So once that goes into the subflow, we set a model. So this template already has a model. So once you import it, you'll have access to the cloud hosted model, so you can use it without having to do anything. So the input goes to USB camera. So one of the inputs goes to USB camera. So that's when you hit get image, it triggers the edge device, which is this, and it will click a picture from the camera, and it will send the image to an inference block. It will run some inference, and it will send the output to output 2, and it will send the input to input 1. And both these inputs are going to two separate dashboard blocks. So input 1 is going to image view, which is this view, and input 2, so output 2 is going to inference view, which is what you see on the screen here. So we are done with importing the template. Everything looks good. Now we want to test the application. So first we want to test the application on the cloud. This is really helpful because you want to make sure that your application is working, everything is good to go before you push your application to the edge. So to test this application, I'll upload an image. So I'll work with one of the images. So I'll upload it from the browser. It'll send the image to this block, and it will we can view the images in the image view. So this is what you see in the dashboard, and it will run inference inside the subflow, which is called devices right now. So it'll run the inference inside the subflow, and you'll have inference view. You'll have the results in inference view. So it'll tell us the state, the certainty of the inference, like the percentage of classification, right? So it's 98% certain that the valve is closed. So we can test it out more if you like. Do I have more images? Yeah. So we upload an image, we put label to the image, we send the image to the subflow, and we have an image view that loads that image. So this is an image that I just loaded, and it runs the inference on that image, and you get the inference result. So we tested the application on the cloud as well. So we imported the flow, we tested the application on the cloud. Now this is super cool because now you can build all your application on the cloud, and once you're ready, you can just hit the subflow, select a number of devices that you want to share the application to. In this case, I have 3 devices provisioned. You can also import devices from a file. You can have a CSV with thousands of devices, and we take care of automatically deploying the solution to your edge devices. So right now, nothing is running on edge. Everything is running on the cloud. So the next step in running inference at the edge is also to transfer model to the edge, because the whole point of running inference on the edge is making sure that the model is on the edge and you are sending as little data as possible from the edge to the cloud, right? So to do that, we'll use another flow which helps us in transferring file to the edge devices. It's again available in our template browser. So I can go to templates, I can hit import templates. I have a utility. So this template helps you to transfer a file from the cloud to the edge device, and you can transfer file from the cloud to n number of edge devices, and that's because of Prescient Designer. So I've already this flow imported. So this is what this flow looks like. Just out of the box, it's a file inject mode, so that lets you upload or select files from your browser, and the file path. So right now the model is being saved in this file path on the edge device, and I have one of the edge devices hooked to this subflow. So whatever I inject here, it will get saved in my edge device. In this case, we are using this to transfer a model. So I'll do that. So I have a model file. I can share it with the edge. So it will send the model file, and it will notify you that the model has been saved on the edge. Now this is pretty cool because now let's say you have a new model, you have more data, you retrain the model, and you want to update all your edge devices. all you have to do is come back to Prescient Designer, select the new updated file, select the device where you want to send the model to, and you're done. So you can send the whole host of models on that to the edge device, and those can be a number of edge devices, right? So we are done with this step as well. We have transferred model to the edge. Now, so now everything is well and good. So now what we want to do is associate a device with the template. So we want to make sure that this device, it runs on the so this subflow, it runs on the edge device. So instead of doing inference on the cloud, we want to push everything to the edge, right? So to do that, all you need to do is go to this subflow, select the device. I think I'm having some connection issues because both my devices are disconnected. Yeah, anyways, moving along with the demo, I'll select the edge device. Let's say I select two edge devices. So now two edge devices are hooked to the system, which is the subflow. So everything that's inside this device, this whole code or block, will run on the edge device. So you hit this button, get image. It will trigger my edge device to get an image from the camera, which is looking at a valve. So it will trigger that camera, it will get the image, it will send the image to edge device first. So it will do all the inference and everything on the edge device, and then you can just send the image to the dashboard and the inference result to the dashboard. So I mean, right now in this demo, we are sending image as well, but probably in application, you want to send as little data as possible. So you'll send just the inference result. So you just send the inference result, and or you don't even send the inference result. You send the inference result directly to the database, and that can be accomplished directly here. So you can just import let's say an S3 node, and you want to send the inference results to S3. You configure your S3 bucket, you hit deploy, and instead of sending the data to the cloud, you are directly sending the data to an S3 bucket. All right, so my devices are back up. Yeah. So let's say I assign this device, which is a Raspberry Pi 4, which is the one that you see here on the screen. I assign the device to my subflow. I hit deploy. Now we take care of everything on the back end. So this subflow is using TensorFlow nodes. It has a bunch of dependencies, and we handle these dependencies in the back end. So you don't have to log into the edge device and make sure that everything that's required to run this application is inside the edge device. We take care of all of that. So now you also see the blue wires. So what these wires represent is there's a data communication between the cloud to the edge. So the data is, so this is the cloud block, this is also a cloud block. So there's a data transmission happening from cloud, it's going to the edge, and from the edge it's coming back out to the cloud, to the two views, to the two dashboard views that you see on the right hand side. So now if I hit get image, it will trigger my camera, it will get the image to the edge device, and it will run inference right on the edge device, and it will send us the image and the result in the two view. So this is the Pi that's looking at the wall right now, and it correctly detects the state is closed, and it correctly also detects the certainty. I mean, it's 99% the wall is closed. So this is the end application, right? Now, if you want to scale this to thousands of edge devices, it's just a few clicks of the mouse. So you select the subflow, you associate it as many devices as you want on the system. You're done, and you hit deploy. And the same application is running on full set of devices, n number of devices, and they all can be doing same thing, or they can be doing different things if you move this subflow if you create a new subflow with a different application, and all of that is possible in Prescient Designer itself. So you don't have to log into the edge device and make sure the dependencies, the code is running there. So we take care of all of that in Prescient Designer. So we imported template, we tested the application on the cloud, we transfer the model to the edge, we associated a device with the template. And that was just a single click of a button, so you can select as many devices as you want. We ran inference at the edge. And so when you click on get image, it's running the inference at the edge, it's getting the image, it's sending it to the image view, and it's showing you the inference result, and we are done. This is super simple, and it's simple because we made it simple because we are taking care of everything in the background. I mean, all the hard stuff, all the complex stuff, managing the dependencies, the communication pipeline, the security, all of that is handled in the background in Prescient Designer. And all you need to do is just drag and drop a few nodes, work with template solutions, and you can extend this to anything. I mean, you can have database, you can have analytics, you can have two devices communicating with each other and not even touching the cloud. So Prescient Designer. So Designer is quite flexible, and I hope I was able to show you some of the features, some of our features and flexibility, scalability, agile development. So yeah, thank you. I'll leave a few minutes for Q&A before we close out. And thank you all for making it this far.
Thank you, Ashish. Right now we have 0 questions because we got a few people telling us that Q&A keeps disconnecting.
Even I'm getting some warnings from Zoom.
So you may be spared. We may have to call Zoom to get our money back. But if anybody has any questions, please send us emails, support@prescientdevices.com, or I think a lot of you probably know who we are and just send emails directly to us. We have a form on the website. There's multiple ways to do it. I think Pablo is on. Pablo, do you want to say something?
Oh, I was just wondering if people, if the chat works, or if we can unmute people if they want to ask questions.
Oh, we could do that.
Actually, I got a notification of one of the questions, but I don't see it there anymore.
So we do have one question that comes directly to the panelists through the chat window. And the question is, when retraining, is it possible to see what past images will have a new result based on the change? So if you're, I think the question is basically if you're adding new images, can you improve the result with the old images?
I mean, I think this is true for all machine vision applications. I mean, if you have more data, you'll have better results. And the training process is taxing. I mean, it depends on the number of images you have. So the model retraining might take some time, but it will definitely improve the results, right?
Yeah.
That answers your question.
Yeah, we got another question, which is basically asking about the link to the webinar recording, and we'll have it certainly on the website very soon, probably in the next few days. And we typically send out a email to all the attendees, so we can include that link in the email there. Okay, great. I think, Ashish, thank you. I personally enjoyed it. I think the way that you organize is really nice. In fact, the first version of the template was even simpler, but we wanted to show you that we can load image, from your computer, send it over to this device block, which can be either running in the cloud or in the edge, so you can do testing. Maybe you have to wrap your mind around it a little bit because it's not very typical, but it gives you so much power to design things, and it's in fact very simple. It's mostly drag and drop. So if you have any questions, please contact us. We're happy to help. If you'd like to try Prescient Designer, also send us a note. We're happy to set up an account for you. And so, I think getting low code to be so easy to use to every single person, regardless whether they are technical or not, that's our mission, right? So we would love feedback from you, how to make things simpler, how to make things easier, and how to enable everybody to design this type of super cool, large scale type of solutions. And machine vision is only one of the sensing capabilities out there. Our next webinar is going to be on sound. In fact, you can do so much with sound you may not even realize. Even though there can be a very noisy environment, you can pick out tiny little things in that environment. And we're going to do a webinar with a partner on sound detection next. So please stay tuned for our announcement. So I think we'll end here. Thank you all so much for attending, for your time. And please give us any feedback. Thank you.